This view of Mars shows Valles Marineris, with Tharsis Montes to the west. The map shows the thickness of Mars' crust, based on modeling of the red planet's gravity field by scientists at NASA's Goddard Space Flight Center. The team found that, globally, Mars' crust is less dense, on average, than previously thought. Credit NASA Goddard Ubakmite. Mazarico NASA scientists are one step closer to understanding the evolution of Mars. New evidence shows that the red planet's outer crust, which is about 30 miles 50 kilometers thick, is porous and not as dense as previously thought. A lower density could have important implications about Mars formation, Sander Goossens, a researcher at NASA's Goddard Space Flight Center GSFC in Maryland and lead author of the new study, said in a statement from NASA. Curiosity rover climbing steep Martian ridge photos. GSFC's Planetary Geodynamics Laboratory made its crust discoveries by looking at Mars' gravity field, which was previously derived using satellite tracking data and advanced mathematical tools. Goossens and his team used the gravity field in a modified technique, which correlates the field with precise measurements of Mars topography, or surface features, to make findings of Mars crust density more accurate. Gravity fields allow scientists to understand Mars on a deeper level, literally. Similar techniques have been used, for example, to investigate the Moon's subterranean composition and history. Researchers measure a planetary body's gravity field by tracking tiny changes in satellites' orbits as they pass over specific areas that have different gravitational pulls. According to NASA, the Martian crust was found to have an average density of 2,582 kilograms per meter cubed, about 161 pounds per cubic foot, or about the same average density as the crust on Earth's moon. The Winnemucca Peak was captured by the Curiosity Mars rover in spring of 2017, near Perseverance Valley. Credit NASA's Occultech. Cornell Arizona State University. Previous estimates of Martian crust density relied more heavily on looking at the composition of the soil and the rocks themselves. That's because up until now, the datasets that would produce gravity maps had a low resolution, NASA said. By comparison, the gravity field for Earth is very detailed, because the datasets have a high resolution, according to NASA. As this story comes together, we're coming to the conclusion that it's not enough just to know the composition of the rocks, Goddard planetary geologist Greg Newman, co-author on the paper, said in the statement. We also need to know how the rocks have been reworked over time. To get findings that were more precise, Goossens and his team developed a technique to make correlations between Mars topography, in particular, changes in elevation, and the planet's gravity field. Once they tested their new technique on Earth's moon, and found that the method successfully produced results that matched those found by NASA's Gravity Recovery and Interior Laboratory (GRAIL), the team used its model to analyze Martian surface density. Technicians lift the lander portion of the InSight spacecraft for testing in a clean room facility in Littleton, Colorado. The probe is set to launch to Mars in May 2018. Credit NASA's Occultech. Lockheed Martin. With this approach, we were able to squeeze out more information about the gravity field from the existing datasets, Goddard geophysicist Terence Sabaca, also a study co-author, said in the statement. NASA's interior exploration using seismic investigations, geodesy and heat transport InSight mission is expected to provide measurements that can verify Goossens' findings, in much the same way that GRAIL verified the lunar density testing, according to the statement. InSight is scheduled to launch in 2018 with the Discovery Program mission, and when it arrives on Mars, InSight can probe the interior of this rust-colored neighbor planet. The new work was detailed August 5 in the journal Geophysical Research Letters. Follow Doris Ellen Salazar on Twitter at Salazar_Ellen. Follow us at space.com, Facebook and Google. Original article on space.com.